Question number 10 taken from June 2014, Advanced Level Maths HSC P3. The line L has equation vector R is equal to I plus 2j minus k plus lambda 3I minus 2j plus 2k, and the plane P has equation 2x plus 3y minus 5z is equal to 18. Find the position vector of the point of intersection of L and P, and also find the acute angle between L and P. And finally, a second plane Q is perpendicular to the plane P and contains the line L. Find the equation of Q, giving your answer in the form AX plus BY plus CZ is equal to D. Okay, so to do this question, alright, let us take a look at what we have here. Alright, so for the first part, we got the line L, which has equation 1, 2, minus 1. So 1, 2, minus 1 plus lambda, and this is 3 minus 2, 2, 3 minus 2, 2. Okay, then you have a plane, okay, and suppose this is the plane and this is the line of that meets the plane, that's the point of intersection, and this plane P, alright, has equation 2x plus 3y minus 5z is equal to 18. Now first of all, I'm interested in finding lambda. So this is 2x, so that's going to be 2 times x, and x is 1 plus 3 lambda, 1 plus 3 lambda, then plus 3y, plus 3 times, this is y is 2 plus minus 2 times lambda is minus 2 lambda, so that's going to be 2 minus 2 lambda. Also we have minus 5 times z, and here z is minus 1 plus 2 lambda, so that's minus 1 plus 2 lambda is going to be 18. So adding up, we have 2 times 1 is 2 plus 3 times 2 is 6 minus 5 times minus 1 is plus 5. Okay, so 2 times 3 lambda is 6 lambda, 3 times minus 2 lambda is minus 6 lambda, minus 5 times plus 2 is minus 10 lambda is equal to 18. Plus 6 minus 6 cancels out, we are left with minus 10 lambda. 2 plus 6 plus 5 is 13, alright, is equal to 18. If you work that out, you're going to end up with 18 minus 13 is 5 divided by minus 10, and that's going to give us minus half. The position vector of the point of intersection is going to be 1 plus 3 times lambda. That's going to be 1 plus 3 times lambda. Lambda is minus half, and if you do that, already you're going to get minus 1.5 or minus 1.5 if you wish, because it's not difficult. So that's 1 minus 3 times minus 0.5. It's going to give us minus 5 upon, sorry, that should have been 1 plus 3 times minus 1.5, and that's going to give us minus 7 over 2, which is minus 3.5. What am I doing here? So 1 plus 3 times minus half. What is 3 times minus half? 3 times, in brackets, minus half. It's going to give us minus 3 over 2 plus 1. It's going to be minus half. So therefore we have minus 0.5. And then for the second one, 2 plus 2 times minus 2 lambda is 2 plus 2 times minus 2 rather times minus half, and that's going to be 2 plus 1. Okay, so it's going to give us 3. Let's put this in here like this, in fraction. Minus 1 plus 2 times lambda, minus 1 plus 2 times minus half. Minus half times 1 is minus 2 plus this, okay, minus 1 times half is minus 1, minus 1, minus 2, minus half times 2 is minus 1, minus 1 plus minus 1 is minus 2. Therefore I got this here, minus half vector I plus 3 vector j minus 2 vector k, and here we are for the first part. For the second part, we have to find the acute angle between L and P. Okay, so we're going to take the direction vector of the first of the line. What is the direction vector? And dot product with the other one. So it's 3 minus 2, 2. So we have 3 minus 2, 2. Dot product with the plane 2, 3 minus 5. So 2, 3 minus 5. 3 times 2 is 6. 3 times minus 2 is minus 6. Minus 10. I'm going to get minus 10. Modulus of this is going to be square root of 3 to the square plus 2 to the square plus 2 to the square. 2 to the square is 4. 2 to the square is 4. 3 to the square is 9. 4 plus 4 is 8. 8 plus 9 is 17. Root of 17. Second part. Modulus of this one, 2, 3, 5. So 2 to the square plus 3 to the square plus 5 to the square. It's going to give us 25. 9, 4. So I have 25 plus 9 plus 4, 38. So that's going to be a root of 38. So the product of these two is going to be what? It's going to be root of 17, right, times root of 38. It's going to give me a root of 646. Therefore, let's suppose the angle is theta. We're going to say theta is equal to inverse of sine minus 10 divided by root of 646, and so we're going to take minus 10 all divided by root of 646 is going to give us this, and therefore I'm going to say inverse sine and 23.16 degrees, so 23.169 and so on. So therefore the answer should be 23.2 degrees. Here we are. Now for the last part. The last part, we have a second plane Q, and that is perpendicular to the plane P. Okay, so suppose this is the plane P. You have a second plane which is perpendicular, so this is P, this is Q, and the perpendicular plane Q contains the line L. Remember, this line has a point here as well, and that point's been given as 1, 2, minus 1. So that's 1, 2, minus 1. And then the plane P, okay, has equation, which is 2x plus 3y minus 5 is equal to 18. So this one has equation 2x plus 3y minus 5z is equal to 18. We have been told to find the equation of this one. So how are we going to do this? First of all, if this is the line L, what is the direction vector of this line? The direction vector of this line has been given as 3 minus 2, 2. So what I can say is I have 3 minus 2 and then 2. Also, what is the normal to this plane? 2, 3 minus 5. So 2, 3 minus 5. Okay, we're going to use the product of the determinant of the matrices. So this is going to be I, this is going to be J, this is going to be K. So if I block this here, I'm going to end up with minus 2, 2, 3 minus 5. Minus 2, 2, 3 minus 5. Similarly, block this one, I'm going to end up with 3, 2, 2 minus 5. 3, 2, 2 minus 5. Block this one, 3 minus 2, 2, 3. 3 minus 2, 2, 3. Now, let us work out the determinant. Minus 5 times minus 2 is 10. 3 times 2 is 6. 10 minus 6. Okay, so 10 minus 6 is 4. I'm going to call this x. Okay, then I have 3 times minus 5, which is minus 15. There's a minus here. Minus 15. 2 times 2 is 4. Minus 15 minus 4 is minus 19. So we have minus 19y. And then plus here. 3 times 3 is 9. Minus 2 times 2 is minus 4. 9 minus minus 4 is plus 13. So I'm going to end up with plus 13, and this is for z. Now, all of that's going to be equal to d. That's the equation of plane Q, but we need to find d. Now, let's just clean that up. It's going to be 19y plus 13z is equal to d. What is d? X, y, z. Remember, we had a point here. This is x, y, z. 1, 2 minus 1. So we substitute this here. 4 times 1 plus 19 times 2, right, plus 13 times minus 1 is equal to d. It's going to be 4 minus 38, sorry, plus 38 minus 13, and all of that's going to give us d. So what is that? Then 4 plus 38 minus 13, that's going to give us 29. Therefore, the equation of the plane Q is 4x plus 19y plus 13z, and that's going to give us 29. Here we are for this question.